Hello everyone. Welcome to the TA sessions for this deep learning course. So I am Shrutimay Das. I am a PhD student at IIT Gandhinagar. So I'll be taking the TAC sessions on Saturdays. So we'll have around 12 weeks of these sessions. So for this so you must have gone through the lecture videos of the last 2 weeks. So in these sessions, we will mostly be going through all of the any doubts that you have, or you want any help with solving the assignment problems. So of course, you will have deadlines. So the assignments will not be solving those problems before the deadlines. But if you have any other problems, you can just go through them. So this is the first session, right? Can you please mute? So this is the first session. So you must have gone through the first few lectures, which motivates what is this course really about, what really is deep learning, and how it came into how the idea of this neural networks, these neurons came. So before we start, yeah, it would be good if I get to know if you could introduce yourself. So like, why are you taking this course? Are you a student? Are you a working professional? So it will be good to know what are the expectations of this course. So feel free to unmute and uh, yeah, you can talk about why you're taking this course.
Uh, yeah. Hi, Shruti right? If I'm
Hi,
pronouncing.
hello, hi,
Yeah, hi. My name is Avinash.
hi, Nash.
So I'm currently working in an organization in data science, and I wanted to upskill myself by knowing
Right.
this like advanced things related to neural networks and LLMs, right? Which is generally coming up. So
Right.
that is the reason I'm taking this course.
Mhm. So yeah, nice. You mentioned about LLM. So all of you must have heard about LLMs. So the basic building blocks of LLMs are neural networks.
Yeah.
So this course will not go into LLMs because
Mm.
it is only a 12-week course. But yeah, we will try to cover everything, the basic parts of the neural networks that is required for understanding LLMs.
Okay. At least recurrent neural network and all these parts that
Yeah,
will.
we will. So the recurrent neural networks will come in the later parts. So I think the last few lectures will be on recurrent neural networks.
Okay.
But yeah, so before that, we'll be covering autoencoders, which is very important. Then we'll be covering CNNs, and then we'll go into the sequential problems for
Okay.
languages. Yeah, nice.
And one more thing, Shrutima, this we can
Uh,
record this session, right? If
yeah, so actually, I am recording this session. I'll upload these recordings to YouTube, and these links will be shared with you. So you can just yeah, go to that link and view these recordings there.
Okay, yeah. Thank you so much.
Thank you. Anyone else? So what? Okay, I'll try to cover the lectures of this. Yeah, Riaz, you can go ahead.
I am Riaz. I am from Maharashtra and I am currently pursuing my third year BTech in computer science. I took this course because I wanted to make career in data science. I have already done a NPTEL course on machine learning, which was by IIT KGP. So I
Mhm.
wanted to make more enhance my skills in this course. So I took it.
Okay, good. Yeah, now that you mentioned, so machine learning is one of the precursors to deep learning. So you can say deep learning is one type of algorithm for solving machine learning problem. So if you love while going through this course, you may encounter some concepts which are based on machine learning. Like you may encounter something these optimization algorithms, or these something called bias and variance trade-off. So if anybody has any doubts, we can just discuss this here. Machine learning is important to understand this, but it is not that you cannot understand deep learning. So if you have a good knowledge of machine learning, that's good. Otherwise, it's fine. So we can discuss this. Whatever you did not understand, we can discuss in these weekly meetings. Yeah, good. So what are your expectations? I mean, how do you, so I was thinking I'll just go over the concepts that was covered in the class, and in the later part of the meetings, we can go over some code, right? So right now you've just gone through some basic concepts on neural networks. There is not much to code about, but later on when we go to say CNNs or optimization algorithms, we can discuss how to implement these in code. So anything else you that you want to cover in this course that so I'll try to make sure that I can prepare in that.
Yeah, Shrutima. So,
Uh,
Shrutima, like basically when we do the coding and all, right?
yeah.
We at times we fail to understand the background things that is going behind in the model. For example, if I talk with respect to neural networks, right? Sorry,
Mhm.
with respect to a recurrent neural network. So
Right.
there is no if you go through any literature, there is concepts of how it is happening and
Mhm.
what are the concepts going inside that. But when we think with respect to numbers, right, how
Mhm.
texts are being encoded and all, like then it becomes difficult to understand the whole process. We get an overview, but in depth understanding we'll not get. So if we can get any numerical problems, right, if you can take some
Right.
numerical problems and then solve it and show, right, for example, this
Mhm.
is what happens in CNN, this is how a filter goes, and how like I just know some concepts like backpropagation through time. I just heard it, but I don't
Mhm.
know what exactly is happening inside it. If you can explain with mathematics, right,
I
how
see.
how it is happening, then it will be with problem solving, right?
Right.
That would be very helpful.
Okay. Okay.
Because
That's nice.
coding wise, like there are packages, right, which because
Mhm.
generally whenever we write the code we call those packages directly, but like I'm sure many of us don't know what is happening inside. So if you can explain what is happening inside those packages, that will be very helpful.
Yeah, I see. So yeah, that is actually yeah, that is good actually. So because nowadays you have these libraries like PyTorch,
Yes,
TensorFlow, so it is
yes,
very easy to build a neural network. But to really understand the problem, you have to know what factor is multiplying with which factor, or how is your model behaving. So
yeah.
yeah. So okay. So yeah, these concepts of convolution and neural networks of convolution, this PPTT, yeah, theoretically they will be covered in the course. But yeah, so I will prepare some notebooks where we can go over these concepts step by step, like where we get, so there are some problems known as vanishing gradient problems or exploding gradients problem. So we
Hmm.
will go through these problems yeah, in these notebooks.
Okay. So if there is some mathematics, right, just
Mhm.
yeah, it will be very helpful.
Yeah, right. Yeah, anyone else?
Hello,
Yeah, hi.
sir. Can you explain the perceptron algorithm with the three or more variables?
Yeah,
Actually,
sure,
with
sure.
the help of examples, that is good for
Mhm. Okay, so let me share my screen. So my screen is visible, right?
Yes.
Okay. So perceptron learning algorithm. Okay. So yeah, by the way, these notes will also be available in the link that will be shared with you. So you can access these the PDF versions of this note in that folder. Okay, so basically first let's go into what these perceptrons is. So yeah, so perceptron is the basic building block of the neural network. So if you have looked at or if you have somehow seen diagrams of neural network, they are something like this. So you will
So
have
Pradyuman, we see the teams of your screen.
oh, are
Like,
you not able to see my notepad?
no, I see teams. I'm not sure.
Okay, let
I,
me share again.
we can see notepad.
No, no, it's visible.
We are able to see.
It's visible.
Sure. Now is it okay? Now is it visible?
Yes, yes.
Okay.
Yes, yes.
Okay, sure. So when we talk about neural networks, you will see something like this. So if you have seen diagrams or if you Google, you can see some diagrams. This you'll have some bunch of neurons which are stacked together, and you'll have some output here. So you pass your data as input. So if we generally refer to data as x, why x? Because in mathematics you always have to find x. So maybe that is why we always refer to as x. And your x will be of certain size, which we call features. So I'll go into perceptron, but I'm just giving a basic overview of neural networks. So each of these x will have features. Say by features, I mean, let us say I ask you or I tell you that my car has these features, like my car has this engine, this type of engine. My car has this much of power, this much of mileage, and I want you to predict what is the price of my car. Right? So these characteristics, like what is the mileage of the car, what is the engine of the car, what is the, let's say, height of the car, and so on. So these things are features. So depending on the features, you predict what your price of the car is. Or in any general problem, you have some data point, and that data point will have certain features, and depending on that features you will decide what is the I mean whatever task that you want, whether this is a positive data point or negative data point or some other task that you may have. So suppose this data point x that I have here, it has say 3 features. So this is feature 1, this is feature 2, this is feature 3, and these features are connected to all of these neurons. In the later classes you will get to know how these connections happen, how to represent this in a computer or for a code and so on. So all of these are connected to each other, and then this thing propagates something like this. So it will have connections so and so, and then in the final output you will have final after you pass the final neuron you will have some output y. So this is a very basic type of neural network. Now if we go into each of these things, what are these things, each of these neurons? So that neuron is what you saw in this week, maybe a perceptron. What is a perceptron, right? I'm taking which individual perceptron. So so one second. Uh, So these perceptrons are basically it will try to learn one linear type of thing. So when I say linear, you must have seen examples, right? So suppose we take the AND example that we had in class. So you have your points, you have your 0 point here, you have your 1 point here, your 1 point, and this 1 point. And your task was to uh, find the line where, or find the function that says given some x, what is the output of that, whether it is 1 or -1 or 1 or 0. So we're talking about the end example here. So your perceptron or some algorithm would try to learn some line here. Let's say this line, say, and then based on this line, it will make a decision that whether the output that you get given this x, whether it is positive or whether this is negative. So how do they actually work? So when we talk about this, let us say we talk about this function. So let us say we are making a decision based on this perceptron here. And now we say that what happens when we have this, what do these axes mean? Like we have 0 here, we have 1 here. So we have some data point. Let us say we have x, and this x has two features. So this is my feature 1, and this is my feature 2. And based on these two features, you decide whether the point is 0, this point is 1, and so on. So let us say I'll represent this as a vector. My point is 0, 1.
Excuse me, sir.
Right.
Sir, can you explain how you draw the line on 0, 0 behind the
Oh,
negative?
you mean this line?
Yes, yes.
Oh, this is just an arbitrary
0.
line that I do. It could be
Means
any
you
line.
select it randomly.
Yeah, so it can be this line, it can be this line. I'm just showing an example. Say I have this line, and I want to make a decision how, using this line, whether I want to, what is the decision that I get. So when we talk about perceptron learning, the task is to learn this line, the slope of this line. So if your perceptron has not learned a good line, it will say that okay, this is the line that I want, but this one is not a good line clearly. So the
Means
perceptron
like
learning
a
algorithm,
two line, you assuming a line.
yeah, like a blue line, it will either learn this line or it will either learn this line or this line, right? So the perceptron, over the course of this perceptron learning algorithm, it will try to correct this. So first of all, let us say it learns something like this, and it sees that okay, this is not a good line. So now it will try to correct it. So at the next iteration, it will say it will be a better line. In the next iteration, and until convergence, it will try to learn a good line until the number of errors that we have is reduced. So that is why this is a learning algorithm. So based on whatever decision it gives at a certain iteration, it looks at the decision and decides whether it is a good line or this is a not so good line. And if it is not so good line, it will try to correct it. It will learn how to make a good line or learn how to draw a good line. So that is why this is referred to as a learning algorithm.
Okay, sir. Continue, please.
So suppose yeah, I'll talk about this end algorithm itself, or the end problem itself. So given this 0 and 1, or as you were saying for 3D, right? So let us say we have some more lines here. Okay, so let us say we have something like this. So we'll have some, this is my 0, 0, 0 point. This is my, let us say 0, 0, 1 point. This is my 1, 0, 0, and this is maybe 0, 1, 0. And now I want to find the, so one thing, when you are talking about two-dimensional space. Two-dimensional, I mean you have just two features. You can just say that this is a line. So when we go to 3 dimensions, that is we have 3 features. So then what, instead of a line, we'll be learning a plane. So you have a plane, something like this. We'll be learning a plane. And this based on this plane, we'll say that okay, if my point lies above this plane, it is +1. If my point if my decision lies below this plane, it is -1. So are there any questions? Okay, are you able to see my screen? Someone said he's not able to.
Yes, sir, it's
Yes,
visible.
it is.
Okay.
It's visible, sir.
So now maybe you can rejoin the meeting. Maybe you have some connectivity issue. Okay. So when I say when we are talking about 3-dimensional space, that means you have 3 features. So let us say this is my feature 1, this is my feature 2, and this is my feature 3. So now my data points will be represented in this way. We have some, say, 0 here, 1 here, 0 here, or something else like 0, 2, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, and so on. So if we look at it in a how it will be given as an input to the perceptron, you have this perceptron here. You'll have x1, you'll have x2, and you have x3. So by x1, x2, x3, I mean this. So I will just say that this is my data point x. The first feature is x1, second is x2, and third is x3. And I'll pass each of these features of the data point into the perceptron. So now the your point. So what you're trying to learn is this W, right? So for each of these features, it will try to learn a W. So for this, suppose you have W1, for this you have W2, and for this W3. And using this W1, W2, and W3, it will try to adjust these weights. So suppose we say that this x1 is more important for making the decision and x3 is not that important. So it will try to increase the weights of x1 and try to decrease the weights of or try to increase W1 and it will try to decrease W3 because it is not so important. So that is the significance of weights. So why you need weights? Because given these features, we want to see which features are more important and which features are less important. So let us say in the example of a car, we know that the mileage is a good or important thing to decide what type of car you want, right? But we are not worried what is the, let us say, the paint of the car. That is not that important. So if we have a feature called paint, that feature will have it will not have that much of importance compared to, say, the mileage of the car. So that is, so how we learn, we cannot just, because there may be hundreds or thousands of features, even millions of features. You cannot go and say which features you think are important, which features you don't think are important. So the model will try to learn which features are important, which features are not important. So when we say model learns, so when I say the term model learns, it means it will learn the W's, right? It will learn the W's. So these are also called parameters, but we'll get into that later. It will try to learn these W's. So now we have this, right? And the perceptron learning algorithm will now try to compute this sum. Okay, so I forgot if this is output. Okay, it will try to have this sum. So because we have 3 features, we have I equal to, okay, so the numbering is 1, 2, 3 in this case. So I'll also use a 1, 2, 3 numbering here. So 1, 2, 3. So we have wi times xi, right? And now let us say the w's are random. By random, I say that say I think I set w to be. So one thing is to set w1, w2, w2 to be zeros and then start over, or I can say that my w1 is, let us say, 0.5, w2 is say 0.081, w3 is 0.3, let us say. So this is a randomly initialized bits. And now we'll make this computation. So let us, we have 0.5 times x1 plus 0.01 times x2 plus 0.3 times x3. I'll get something here. And now let us say that this sum is less than 0, right? If this sum is less than 0, that means if we look at this plane, right, and I say that anything great, anything positive, and by positive I mean on this side of the plane is greater than 0, and on this side of the plane is less than 0. So this is, let us say, some f. This is, let's say, I mean that we learn how to draw this plane. We learn this plane, and anything which is on this side of the plane, we will say that okay, this is a positive, or greater than 0 mean positive point, or if the lies below the plane, I will just say that it's a negative point. And how we learn this plane? We learn this plane using this ws. And now suppose we see that this summation is less than 0. So that means our weights are small, right? Because suppose we are given this example, say 0, 1, 0, and 0, 1, 0, where does 0, 1, 0 lies? It lies just on the plane. So 0, 1, 0 is what? It is 0. But we want it to be equal to 0. Let us say. For that example, let us say that this is minus 0.5, minus 0.3. So these are randomly initialized for,
Excuse me,
yeah,
sir.
yeah,
See, here is threshold is we taking 0. But
yeah. For
threshold
this
may
example,
be
I'm,
any other.
yeah, come again.
Here you assume the threshold 0, or
Right.
in our algorithm or assignment, there is also 0.
Mhm.
But in some book or any other anywhere, there
Mhm.
should be theta, like it may be anything.
Yeah, yeah.
So what we should take it either 0 or take anything, or which is given in
So,
the.
so yeah, that's a good point actually. So for this example, we just want to say where your uh, add function gives +1, or whether it gives 0. But there may be some other example which is not a Boolean function like this. So there you will want that you will have some threshold. Say I want my function to be greater than theta, and if it is greater than theta, I will output +1. And if my function is less than or equal to theta, let us say, we'll say that the function is -1. So in that case, instead of this 0, you can just compare with theta in that case. But there is one other trick that you can do, is inducing something called as including something called as a bias. So what I mean is that, so suppose, okay, let us say that instead of, let us not take this end example. Let us say we have some theta. Say this example. Say if my output is greater than theta, If my output is greater than theta, I will output +1. If my output is less than equal to theta, I will output -1. So how do I design this? So for now, let us say we have this x1, x2, x3, and I will include an extra variable. Let us say -1 here. So now my problem becomes a 4-dimensional problem. And how do I change the perceptron? So earlier you were just taking this x1, x2, x3, and now let us say I will just have this x1, x2, x3, and I'll have an extra -1 in this case. And this I will initialize as some w0. This is w1 to w3. So if I write down this summation here, I will do 0 to 3 wixi. So this is basically your minus w0 plus w1x1 plus w2x2 plus w3x3. So how does this help? So let us say we know that this, not this one, yeah, we say that this is greater than or less than theta, right? And suppose we want that this should be greater than, 0, and let us set w not to be theta. So then we'll have w1x1 plus w3x3 minus theta greater than 0. So that means we will have w1x1 plus w3x3 greater than theta. So if this happens, then yes, your algorithm it outputs whatever you want it to output, say +1. Or if it is minus less than theta, you'll just have you'll have the other thing, like whatever, say you want to output -1, it will output -1. So when we talk about this, so for easy cases, we just talk about this 0. That otherwise we include an extra variable here, we say it is -1, and we include some w not equal to theta, such that your threshold, it depends on what prior information that you have. So this is called bias. So that means this is some bias that you have, like for some example, you want your output to be, say, greater than, let us say, 0.8 and to be +1, and you want it to be less than 0.8 to be -1. So this 0.8, it depends on maybe the experience of the user, or some prior information that you have. That is, you are giving some bias to the model, that I'm biased, that I want my outputs to be greater than 0.8. So then you add this bias to the learning algorithm. I hope that is clear.
Okay, sir.
Okay. So coming back to the perceptron algorithm, so we were looking at this summation, right? So this is the summation that you have, and we want that all of my there is convergence, and by convergence I mean you have 0 error. That means all the points of all the points which lie in this region, say whose function value is greater than 0, should have greater than 0, otherwise you'll have less than 0. So you have to adjust the weights in this case, right? So how do you adjust the weights? If you see that your summation is less than 0, that means it is your weights are still small in some sense. You have to add to the weights, right? So then you add this x itself. So you have some w, which is, let us say we include w1 also, w0 also, and you have some you have these x's. Let's say x. and your new w's will be w plus x, which is basically summing over this algorithm. Or if your let us let us say if your summation is greater than 0 and you want it to be small, you subtract the weights, which is you just put a minus, you put a minus in this case, w minus x, and you continue this until you are satisfied that okay, there are no more problems or there are no more errors in the data set that you have. So that is the basic run of the perceptron algorithm. So one thing to note is that here the updates are just simple w plus x and w minus x. Later on, when you go for optimization algorithm, we'll see what else we can add. Instead of just adding the x or subtracting the x, we can add more information than that, depending on the feedback that you get. So yeah, so that is the perceptual learning algorithm. And for this, I showed it for 3 inputs. You can do it for n number of inputs. It does not matter whether it is 1, 2, 3, 4. It does not matter. You can just do it because this is just a summation, right? Between wi and xi. You can do it for any number of inputs you have. Is that clear?
Yes, sir.
Excuse me, ma'am. So instead of
Hi.
theta, we can use the W0 now. That is another weight we have given anyway.
Uh-huh.
Instead of theta, we can directly use the W0. Why particularly we can use a theta?
Oh, so I'm saying that theta, if you know theta, if you know that, okay, I want my output to be greater than 0.8, you'll just say W0 to be 0.8. But in some cases, it may not be so that you know that it has to have some threshold, but you do not know. So you just let W0 be W0. And then over the, because this perceptron algorithm will update the weights, right? It will also update your W0. So it will learn itself what the threshold should be so that you get your +1 or -1. So you can either fix it to be theta or you can just keep it as W0 and it will learn what the W0 should be.
Thank you.
Yeah, any other doubts, any other feedback?
Sir, can you suggest any other reference book which contain the more numericals?
Okay, so
Book or site or any other reference where we
okay.
can do the practice?
So there are these let me see. So one okay. So there is this website called d2l.ai. It does not have numericals in that sense, but you still have a lot of your code that you can play with. So suppose you want to implement convolution neural network, say. So it will have an example of how to implement it in different libraries, say PyTorch or TensorFlow. Or you can just do one thing. There are several courses available. I think CMU or Stanford will have their online courses available online, so you can find it on YouTube. And if you
Sir,
go, okay, uh-huh.
sorry to disturb you, but in these type of the courses, actually the content is limited, and we have
Limited, you mean?
material is less in all
Yeah, I
other.
did not get you. Can you repeat?
Okay, sir.
Hello.
Please continue, and please
Yeah, yeah, no,
if you okay,
I did not
please
get
continue.
what you were saying. Yeah, can you repeat what you said?
Actually, the content on these type of the courses are limited for the practice. They are just explaining the concept and give one or maximum one or two examples for a particular problem. But we need the actually 3 to 4 example of a particular problem. If you have any type of the book or reference or any other reference videos, then please they can help us.
Yeah, hmm, so let me check. So there are certain courses. I'm trying to share the link. Hold on. So I am sharing a link in the chat. Uh, yeah, someone mentioned Andrew Wang in the chat. Yeah, so Andrew Wang's course such a deep learning course by Andrew Wang that is actually very good. Yeah. Yes. So I've shared a few links in the chat. They have a list of videos that you can go through, and they will also have a. So if you go to their website, so you go to the comment section, they have shared the website for their course. There you will be able to find some problems that they have. Uh, this- So I have shared one more link. Uh, so I've just shared a link for Stanford course. You will be able to find similar courses from MIT or CMU where they have these lectures all available online, and also they will share the links of their courses. So if you go to their websites, you will be able to see some sample problems that they have. Specifically, if you want to look at some numerical problems, they will have these.
Okay, thank you so much, sir.
One. Yeah, try to look into the courses of these institutes, CMU, Stanford, and MIT, and they will have some somewhere where they give some tutorials or some problems where you can practice. So other than that, there is this book called Deep Learning. I think the PDF of this will be available online. You can also go through that. Let me share it if I have. Okay, so Bhavesh is asking, can you recommend something that? Yeah, so this course will not go into LLMs because before going into LLMs, you have to understand how these neural networks work or how the sequence models works. Because LLMs are a bit advanced because you before that you still have to learn about transformers. So if you want to learn about LLMs, you can go into this. I think Andre Karpathy has some good videos on how LLMs work. Uh, but it is not. It is a bit advanced if you're just starting out in deep learning. You must first cover what are the basics of deep learning. Then it will be easier for you to understand. Else it will be a big step up if you're not if you don't have much experience with deep learning. So I'm sharing another link. They have a link to the PDF called deep learning. So this is a very good book actually. You can just go through this book and try to see mostly the basics first. How to how this learning happens. What are the metric linear algebra type of techniques that you need to learn. So you can go through this book. You don't need to go through all of the topics, but some of the topics may be helpful for you. Yeah, are you able to access this book that I just shared? You may face some issue. Okay. Okay, link is there. So I also shared a GitHub link. You can see if you can access this. So the title of the book is Deep Learning. Okay, I am not sure what about this hands-on machine learning that you. I'm not sure about that. So, so this is a so for deep learning. I don't know. Machine learning will have a different type of algorithm there. So it may have one of the chapters as deep learning. So I'm not sure what about this hands-on machine learning book. If you have a link, you can share. Then I can see about that. So this book I'm referring to by Goodfellow. So you can just search for this book. You will have a This is freely available online. You can just download it from there. Yeah, Lalita, is there any question?
Hello, can you hear me?
Yeah. Yeah. Hi. Hello.
Yeah, hi. Uh, I just came on this machine learning entire thing a few months ago, and I kind of liked it, and I started doing it. I'm not a student. I was working about 15 years ago. I'm a computer science engineer, and I was a break. I was taking maths tuitions and all.
Okay.
And I kind of liked this machine learning so much that I did some few 3-4 courses. Currently also I'm doing some LLM course from YouTube. It's very interesting and nice. So I had this because I'm currently not in industry. I had this doubt, like if I'm taking anything from Kaggle or GitHub and trying to just learn something, the data is not cleaned. And I don't know so many libraries to what all to do. Simple, really baby stuff I was able to do. But it otherwise, are they dedicated people to do the data cleaning, prepping the data? That is
Okay.
like a doubt that I had because currently I'm not in industry, so don't know.
Okay.
Are we
So
supposed to know so much about data science in depth so that you can do yourself the entire thing? That was a question.
okay. So yeah, even I am not that much in industry, but okay. So uh, if you're taking some data set from Kaggle, so Kaggle will have for a given data set, Kaggle will show that these are the submissions that you have. So
Mm-hmm.
maybe you can take the help of those submission and see how they are cleaning this data, like how they are dealing with these missing values or these outliers. So that is
Yeah,
one
no,
thing that I
yeah.
can
I
suggest.
mean, that was not the question. Question was like generally, like if anyone else also knows in the industry, they can answer probably.
Uh,
Are
yeah,
there
if anyone from the
dedicated
industry,
people? Yeah,
yeah, yeah.
it's
So if anybody is knows about this, he or she can answer. Even I'm not in the industry, so I don't have that much of an idea about this.
I think you can
because
do that by pandas.
no.
Yes.
The question is like those things are there. So if I am doing this machine learning, am I supposed to learn all those libraries as well for data cleaning? What I mean, just for the sake of learning, or I need to be know really well. It was my question. Or
It depends
generally
on your
they
goal,
are.
right? If you are trying to,
No,
if
my
you're
goal
going
is
to,
not for
practice this,
data cleaning, more on machine learning. But then this is like a very prerequisite. Without a clean data, you can't do anything at all. Uh, so that was a so that becomes like a different stream by itself. Was I had always this doubt.
So for data cleaning, so as far as I'm aware, there are some certain steps like people always do. They do this EDA and all of these things, and I think it will come with experience. So you don't have to learn all of these things. Based
Okay,
on my experience, yeah, it comes with experience that you will know which things to do. You will just know that you have to center
okay,
this data, you have to remove these bad points. So
okay,
yeah, it may seem frustrating when you don't get some good images or something. But as
Yeah.
far as I am aware, it will, you don't have to specifically learn it, I guess. But
Okay.
if
Okay.
someone is more knowledgeable about it, maybe, I'm not sure.
Yeah, because one by one, I was like, I went pandas and then okay, try doing one small thing, and then okay, so much was there in depth that I
Yeah,
was
yeah,
like,
yeah.
okay, that is deviating from my topic. That so I wanted to just try out some code, but my data was not clean, and I
Mhm.
ended up doing something in a decision tree, and a
Uh,
really bad decision tree came up. But yeah, so I was like, whether should I do that also or not? Kind of. I
so
thought like you not required. There would be dedicated people or a team would be there to do is what I thought.
So
Maybe I'm
in
wrong.
general, so what I have seen in academia, at least when people are creating these data sets, they employ a
Hmm.
lot of peoples because labeling
Hmm.
these data set is very hard task. So they
Yeah.
employ hundreds of people to label each and every image or every data point. So getting data like this is a bit tough. So what you can do is if you are using say sklearn or later on maybe PyTorch, they
Hmm.
already have these data sets. You can just download from PyTorch itself.
Okay.
So
Okay.
there are some standard data sets. So there is something called MNIST or CPAR10. So you can
Okay.
just
Okay.
work with those standard data sets because they have
Which are they
already
are
been,
already clean.
they are
Okay.
already clean and people have been working on that, on these standard data sets. So you
Can
can
you just
just,
type it in the chat?
yeah, yeah.
Yeah. Thank you so much.
So if you can look at, so sklearn will have some data sets.
Yeah, I
Go
did
to
not know that.
sklearn. Uh-huh.
Scikit-learn library I knew, but it has got its own data set. I did not know.
Yeah, so these are some small data sets.
Yeah.
Let me see the link. So yeah. So there is something called sklearn toy data sets.
Okay. Okay.
So these are pretty, you can say, safe in some sense, safe data sets because they are not, I mean, they are already clean. You don't have to do much.
Oh, okay.
Or
Okay.
you can go to something called as UCI dataset. So this
You.
is a repository, UCI dataset. So
Okay.
this is a repository of hundreds of dataset. So
Okay.
you can go to this, or
Mm.
there is something. So even PyTorch or TensorFlow will have inbuilt dataset there. You just have to
Mm.
look into how to extract this dataset. So code for this will be available. That's 2-3 lines of code.
Mm. Okay.
So you can go to these resources. So if you are say you talked about decision trees, right? So
Yeah.
for decision trees, sklearn dataset, these toy datasets will be enough
Okay. Okay.
because they are simple datasets. So you can go
Oh.
through these resources. You don't have to. Yeah, instead of Kaggle will have very open source dataset, but these
Yeah,
sklearn and
I mean, I
UCI
was
dataset
not
will have.
aware. Yeah, I went to Kaggle and something I just
Uh,
downloaded and something and all I just deleted instead of I
yeah,
didn't
and
have the
also,
patience like what all to do.
yeah, that is right. So this sklearn and this UCI dataset, you can just call their functions and you will
Okay.
directly get this X and Y matrices. You don't have to create
Oh,
them specifically. So it becomes
okay,
very
okay,
easy after that.
okay. Thank you so much.
Yeah. Okay, so Bhavesh is asking if there will be any projects. So this course will not have any projects. Is just it will just introduce you to the basic concepts of the different algorithms that you have. So for projects, yeah, so Kaggle will be a good place to start. Or you can just go to the PyTorch or TensorFlow documents. They will have a lot of work that you can do there. A lot of say problem statements that you can try out, or these things. Yes, I. is d12.ai. So yeah, there will be no projects here. You just have to find them yourself. So you can just okay, there is this website called Fast AI, I think. Let me check. So this Fast AI has a lot of projects on their website. Fast AI. Huh. You can go to this website fast.ai actually. So they will have a lot of projects mentioned on their website, and even how to implement neural network from scratch. So you can go through uh, their website. So that will be very helpful actually. Is d12.ai and fast.ai. Okay, so final exam pattern. So your final exam pattern will be uh, will have. So I've never given this exam, so I cannot be sure, and I'm not involved in setting the exam. But as far as I'm aware, you will have this multiple choice type of questions in the final exam. The same type that you have in your assignments. There may be a few numericals in the sense that what is the size of this, or how many layers do you need, such type of questions. So it will be theoretical. You don't have any coding component. Okay. Anything else? Any other thing you want to discuss? This last week. So in later parts of these lectures, uh, will go through some optimization algorithms. So for that, a small amount of knowledge about linear algebra will be helpful, and so calculus, high school calculus like differentiation, chain rules, that will be helpful in I think after 2-3 weeks of these videos you'll need those. But other than that, uh, this is it is mostly self-contained course. Okay, so tomorrow, yeah, tomorrow we'll have a session, but I will not be taking the session. So I will be taking this session on Saturdays, and I have one on tomorrow and one on Tuesday, I think. Till Monday and Tuesday, I think. So those will be different. Some other TAs will be taking those. I'll be taking on Saturdays only. Okay, how to update the weight if the output is not correct, right? So if you go through the perceptron learning algorithm, you will have this thing where they check whether your summation is greater than 0 or less than 0. And if it is greater than 0, uh, you want that, okay, I want my weight to be less than 0. So then you decrease the weights, right? So what we mean decrease the weight, you just say currently I have this W, I subtract these weights, and for the next iteration, my weights will be this updated set of weights. Or you can increase the weights if it is the other way around. So if your output is not correct, you will have some loss. That means your algorithms will know that okay, I have to change something, so it will update the weights in that case. Correct, right, Rakhi? Is that clear? Yes, Vasant. So these recordings will be uploaded to YouTube, and this will be the link for that will be shared in an Excel sheet, so you can access the recordings from YouTube. Sujit, I'm not did not attend start. So this is the video lectures will be released each week. This is just doubt clearing, or later on we'll have some coding problems class. So you can watch the lectures, video lectures at your own time. But take care that the assignments will have certain deadlines. So you have to finish those assignments before the deadline. But other than that, you can do the lectures anytime they are free. So by class every week, I mean, yeah, the video lectures will be available online. You can watch them anytime you want. And this tutorial session will have every week. Yes. So you'll have 4 tutorial sessions. So
Sir,
on
excuse me.
Saturday, I'll be taking. Yeah.
Sir, assignment will be coming randomly or with a certain time of period?
Oh, so each week a new set of videos will be released, and for that week you'll have for each week you'll have one assignment.
Okay, sir. Thank you.
So yeah, regarding machine learning, it will be good to know a little bit of machine learning, but even then, I think this course, if you go through the videos, you will be able to catch up with it because not that much concepts of machine learning will be required. Other, if you even then, if you still need some clarification, you can discuss those ML based doubts in these sessions. Okay, so Lalita, yeah. So my sessions will be, I'll try to cover doubts as well as later on we'll go into some coding or mathematical problems. I'm not sure what other TAs will cover, but it will mostly be similar, mostly be doubt clearing sessions or problem solving sessions. So yeah, so today I will be taking the doubt clearing session. So today, so these interactive sessions are the doubt clearing or problem solving session. If you have some doubts, we can discuss it in this session, or else we can also look into problem solving. Yeah. So these interactive sessions are about doubt clearing or problem solving. So if you are unable to attend on Saturday, so some other TA will be there on Sunday, Monday, or every Wednesday. So you can even attend those sessions.
Sir, is there any attendance or marks to taking the problem class or not?
No, no, there is no attendance or marks for it. you are, I mean, if you're free, you can attend, or else if you're okay, so then it's fine. If you don't want to attend, there is no it is not mandatory.
Okay.
This, I mean, we have this 2 hour slot, so we'll be available to answer any questions that you have. But from your side, it is not mandatory. Yes, so these 2 hour sessions will be there from, yeah, so on Saturday, Sunday, Monday, and Wednesday. You can attend any one, you can attend all of them. It's up to you. No, no, it won't be a problem if you're unable to attend these sessions. Anyway, the YouTube recordings of these sessions will be shared with you. The links will be shared with you. You can just go through the recordings if you are unable to attend this session. Like, so if you're trying to work on these algorithms, it will be good to brush up on Python. Not comfortable with it. So Python is pretty easy to learn. You can just learn a bit of Python, and then uh, you can go to these websites like d2l.ai or fast.ai to implement these algorithms. Which website? So these are the websites I was referring to. This d2l.ai and fast.ai. Okay, so let me share. So I've shared the links of two websites in the chat. You can go to those. Yeah, so working on projects is actually a good way to learn because you can only learn so much about the algorithms from theory. But if you work on these projects, yeah, it's good if you can collaborate and do something. So that is a better way to learn actually. It's basically what deep learning.
Okay, thank you so much, sir.
Okay, thank you. So I shared a link in the chat. You may be able to find some good projects there. You can just take out one project, try to implement that, and then from there you can build on from there. Maybe you can try to do some other thing other than that. So for the large data sets, you may face a problem if your system is not okay, if your system is not that good. So for that, you can just go to this thing called Google Colab. You must have heard of it, or even Kaggle has some GPU available with it. You can just run your code there itself instead of just running this code on your personal machine, because deep learning is very compute heavy. It requires a lot of RAM and GPU. So uh, try to run these things on Google Colab or yeah, yeah, this Kaggle. Yeah, Colab is pretty good for most of these basic things. Okay, thank you. So we did not have much to cover during the first week. From next week, when we go into algorithms, we'll have some more topics to discuss. So no, so assignment one deadline has not yet passed, so I cannot discuss questions from assignment one. We can discuss it after the deadline next week.
Sir, I believe assignment 1 and 2, the dates are the same to submit.
Yes, yes, 2nd February, I think. So after the deadlines, we can discuss the doubts.
Okay, sir.
Sir, we got a mail regarding tomorrow's session. Will it be the same you, sir, taking the session or some other?
So I will not take that session. Some other TA will take the session.
Okay, thank you.
So I'll be available till 5. If you want to discuss anything else, we can discuss. Else, if you are, yeah, if you want to leave, you can leave.